part is about the determination of the numerical aperture and acceptance angle of the optical fiber. So for this I need a laser source, optical fiber cable and the connectors. Okay. So the acceptance angle can be calculated by using this formula. Theta is equal to small r divided by d into 180 by pi. Here theta is nothing but the acceptance angle, small r is the radius of the circular image and d is the distance from the fiber end to the circular image, and from this we can calculate the numerical aperture by using the formula numerical aperture is equal to sine of acceptance angle. So this is the laser source. So the fiber optic cable, one end of the fiber optic cable is connected to this laser source and the other end is connected to the screen. So as we have studied earlier, in the fiber optic cables, the light is being communicated by means of total internal reflection. So I can calculate the acceptance angle by measuring the distance from the fiber end to the circular image and by measuring the radius of the circular image. So initially I have fixed the laser light in the first circle. So this is my screen. I can measure the distance between the fiber end and the screen by seeing these lines. So first I have fixed the light in the first circle, that is 10 mm circle. So I have to see the distance here. So it is exactly at 1 centimeter. And now I am moving the light to the second circle, that is my light is fixed at 20 mm circle. So now the distance between the fiber end and the circular image is 2.8 centimeter. Once again I am going to fill the light in the third circle, that is 30 mm circle. So now the distance is 4.4 centimeter. So now by substituting all these values in this formula, that is R we know, that is 10 mm, 20 mm and 30 mm. The distance small d we know. By substituting this R and D values in this particular formula, I can measure the acceptance angle. So the mean value of this particular column will gives you the acceptance angle. So by knowing the acceptance angle, you can measure the numerical aperture by substituting in this formula, that is sine of acceptance angle will give you the numerical aperture.